In this chapter, we will be looking at rational expressions. In this lesson, we will be solving rational equations.
So now we're going to take a look at solving rational equations. And really the idea behind this is that we don't want to be solving equations with fractions. So what we're going to do, and you're only able to do this with equations, okay, because of the presence of the equal sign. What we're going to do is we're going to get rid of it. We're going to change the question. We don't want to work with fractions, so in this particular circumstance, we actually have the ability to say, okay, I'm not going to. We're going to change the question into something that's easier to work with. So this is how you do it. You're going to factor all the denominators. Now you should probably factor everything, right? You should probably factor and cancel if you can. Okay, factor and simplify numerator and denominator if you can. But specifically, we're looking to factor the denominators. We're going to state the NPVs. That's really important, okay, because that can come back later on at the end of the question. Then what we're going to do is we're going to multiply everything through by the lowest common denominator. Now, until you've seen that happen, that probably doesn't make much sense when I say that. But you'll see me do it every time here, and that'll make sense after a bit here. We're going to simplify and solve for x. Then once we solve that for x here, because what you should be left with after getting rid of those denominators, okay, or at least after step 3, what you should be left with is a polynomial. And then when you solve that, all you got to do is just check to make sure that your solution isn't one of the NPVs. Whatever you're left with, those will be the answers to the equation. Okay. Now again, that little description there is probably not enough to go on. Let's take a look at some examples. Okay, so here we go. Pretty straightforward example here. So what we're going to do first of all is factor all the denominators, and they are factored. Okay, they're basically as simplified as they're going to get. And the best that I can say in terms of non-permissibles here is that x can't equal 0. Now, multiplying those two denominators together, I'm going to see that my lowest common denominator is going to be 3x. Now I'm going to kind of write this over here. Okay, there's my lowest common denominator. Now what I'm going to do is I'm going to multiply this through by every term. Okay, and so when you multiply this by every term in this equation, essentially what's going to happen here is every numerator is going to get an extra 3x in it. So this is going to be 5 times 3x over x plus 2 times 3x over 3. And on the right-hand side, it'll just be 4 times 3x. Every numerator. Every numerator. Mistake a lot of people make here with this is they just don't do it to every term. Okay, every numerator gets this. Now, because I chose the lowest common denominator, every one of those expressions that I multiplied through is going to have a piece of the denominators in them. So here, x and x will cancel. Now that would normally be a problem, but remember, we've already stated that x can't equal 0, so that's fine. That's going to leave us with 5 times 3, or 15. Here, the 3's will cancel. That's not a problem. That's going to leave us with 2 times x. And on the right-hand side, we're going to get 12x. And again, with the understanding that x can't equal 0. Now, 15 plus 2x equals 12x. Well, that's substantially easier to work with. I'm going to subtract 2x from both sides just to get the x terms together. So that'll leave me with 15 equals, well, subtract 2x out, and I'm going to get 10x. Okay, where x can't equal 0. And now to get x by itself, I got to get rid of this coefficient, so I'll divide by 10. Again, as long as x can't equal 0. And then you can simplify that. There's a common factor of 5, so 3 over 2 is equal to x, where x can't equal 0. And that's what we're trying to look for here. Okay, so there's a solution. And the solution isn't one of the non-permissibles, or it isn't the non-permissible, so that is the answer. Let's take a look over here. Again, our first goal here is to factor, and it is. It's as simple as it's going to get. Except in this case here, we can say that x can't equal 5. Now, my lowest common denominator, okay, now don't look at this and say, well, there's a common 5 to both of those. No, it's not. Okay, because we're always looking at factors. 5 isn't a factor here. It's an addend. Okay, it's being combined with the x. So I'm going to have to multiply those together. So my lowest common denominator is going to be x times x minus 5. That's the thing I'm going to multiply through. So every numerator here is going to get an additional, so there's 3x plus 2, it's going to get an additional 5, x minus 5. over x minus 5. And that's going to equal 4 times 5 times x minus 5 over 5. And that's all going to work so long as we don't allow x to equal 5. Now on the left-hand side, the x minus 5s will cancel. That's good for every value of x except 5, but that's okay because I've already pointed out x can't be 5. And so we're going to be left with 3x plus 2 times 5. Now, that's just an easy thing to do. I'm just going to distribute that through. I'll just do that right now. That'll be 15x plus 10. Over here, the 5s will cancel. And it does that without any difficulty at all, because 5 divided by 5 is 1. I don't have to worry about anything. And then I multiply that 4 by the x minus 5, and we'll get 4x minus 20. And again, got to state it, x can't equal 5. Okay, now, we just got to solve for x. This is a nice little polynomial equation. It's a linear one too, so I'll bring the 4x over, and I'll bring the 10 over. Okay, remember, I'm going to subtract 4x from this side, which means I got to subtract it here. I got to subtract the 10 from this side. I got to subtract it here. Again, including the fact that x can't equal 5, and now I'll divide by that 11 to get x isolated. And so I get a solution of negative 30/11ths. Okay, well, that's not a really pretty fraction, but it's not so bad. It could have been worse. Could have been a lot worse. And it doesn't match up with the non-permissible, so I assume that's the correct answer. Okay, let's keep going. All right, this one right here, again, my first goal here would be to factor, but they're all simplified as much as they can. So what I'll do right now is just state the non-permissible. X can't be equal to 0, and x can't equal positive 1. Okay, I can't really simplify anything. Remember, these are not common x's here. Okay, they're not common because before I could do the division, I would have to do what's in brackets underneath it first. So no, that's as good as it's going to get. But I can create the lowest common multiple here of the denominators, and that's what I'm going to multiply through. So every numerator is going to get this x and an x minus 1 here. So this will be 3 times x minus 1 over x plus 5x times x minus 1 over x minus 1. And I got to do the same thing on both sides. Okay, so that 5 all by itself is going to get the x and the x minus 1, and that's all good so long as x does not equal 0 and 1. That's a long line there, but that's okay. Now, I'm going to do the canceling. Now remember, I've already stated what the non-permissibles are, so I'm going to be free to do this. So those x's are going to cancel. And now what I'll do here is I'll distribute that through. I'll get 3x minus 3. The x minus 1 and the x minus 1 will cancel here, get us a 1. And then I'll distribute, I'll just multiply those together. That's going to be 5x squared. And then over here, well, there was nothing in the denominator, so basically I just have to expand that out. So this is going to be 5x times x, 5x squared, 5x times negative 1, negative 5x. And again, where x can't equal 0 or 1. All right, so now I'm going to simplify. I'm going to bring the 5x is negative over here. I'm going to bring that over. But notice right away that if I try to bring the 5x squared over, oh, looky, they're gone. So I'm going to get 8x here on this side when I add 5x to both sides, and then I'm going to bring that 3 over, where x can't equal 0 or 1, and then divide by 8. And there we go. So x equals 3 eighths, as long as I don't allow x to equal 0 or 1, and it doesn't. So 3/8 is my solution. Next. Okay, this one would need to be factored here, but it sort of already is, as long as I understand that this x squared means that there are 2 x's here. Because notice there's 2 x's here, there's an x here, there's an x here. Okay? I might want to rewrite this. Think about it like this, though. Maybe I'll write it below here. The 15 and the 5 carry a common factor of 5. Okay? So between the 15 and the 5, really the least common multiple here is going to be 15. So my common denominator here would be 15x squared. This is the smallest it could be. Okay? It's got to be at least 15. Okay, in order to be a common factor. Okay, so 5 is going to work up to 15. And then it's got to have at least the two x's because this one's got two x's here. So now the only non-permissible here though is that x can't equal 0, which is kind of nice. That simplifies that down a little bit. But now I'm going to multiply this 15x squared by all denominators. Sorry. Ugh. By all numerators. So this will become x minus 3 times 15x squared all over x squared will equal 11 times 15x squared all over 15x minus 2 times 15x squared over 5x under the condition, whoops, it's off the screen, that x can't equal 0. Now I'll do my simplifying. Now because x can't equal 0, I've already dealt with the issue that might have popped up here. So the x squareds go away here, and I'm left with 15 times x minus 3. Let's just do that. So 15x minus 45. This is kind of neat here. My 15s cancel. One of my x's cancels, and so I'm just left with 11x. It's kind of nice. And then here, this will be minus 15 and 5 is going to leave me with an extra factor of 3 up top there, and then one of the x's cancels. So I'm going to be left with 6x, where x can't equal 0. That's a wonderful little equation. I'm going to move the 11, oh, sorry, I shouldn't even do that. Let's deal with this first. So we're going to have 15x minus 45 is going to equal, well, 11 minus 6 is 5x, where x can't equal 0. Now I'll bring the 5x over and I'll bring the 45 over. So 15 minus that 5 will be 10x. And then it's negative 45, and when I bring it over, it'll be positive 45, as long as x doesn't equal 0. And then I'll divide, get x is going to be 45 tenths, where x can't equal 0, but I'm not going to leave it like that. There's a common factor of 5 there, so that'll be 9 over 2, where x can't equal 0. And again, x doesn't equal 0, so there's my answer, 9 over 2. Okay, let's keep going. Okay, so this one here, looks like I'm going to have to do a little bit of factoring in order to make this one work to start off with. So to begin with, this is going to be 18 over, well, there's a common factor of x there. So take out the x, I get x minus 3. But notice on the right-hand side, those two factors, are exactly what show up in the denominators here. So that's fine. That's the only little bit that I had to do here. So my common denominator is going to be just the product of x and x minus 3. Okay, so there's my common denominator. And my non-permissibles at this point will be 0 and positive 3. So now I'm going to multiply every numerator through by that least common multiple. So this will be 18x, x minus 3. Well, I love that. There's going to be some wonderful simplifying there. This is going to be 6 times x minus 3 all over x minus 3. This will be 5 times x minus 3 all over x, with stipulation that x can equal 0 or 3. And I knew that was going off the screen just as I was writing it. There we go. So now, let's do the canceling. Now over here, this is great. X minus 3 over x minus 3 is 1, so long as x doesn't equal 3, and it doesn't. X divided by x is 1, so long as x doesn't equal 0, and it doesn't. So this just becomes 18. Love that. Over here, again, same as before, the x minus 3's cancel. We're left with 6x. Here, the x cancels, and I'm left with negative 5 times x minus 3. So it's going to be negative 5x, and then negative 5 and negative 3 is positive 15. Just make sure you're distributing the negative carefully is I guess the best word of advice I can give you. Just be careful with it. Okay? And again, where x can't equal 0 or 3. But now, take a look at this. 6x minus 5x is just going to be x. Well, I love that. And I'll subtract 15 from both sides, and we'll get 3. X is equal to 3, so long as x doesn't equal 0 or 3. Now, I hope you heard when I said that, how goofy that sounded. So the solution is x equals 3, so long as x doesn't equal 0 or 3. Well, x can't equal 3. So as a result, there's no solution. Okay, x can't be equal to this, so it just turns out that this particular equation doesn't have a solution. That's great. There's nothing wrong with that at all. Wonderful. But I know when you're working something like this through on an exam, that's a very disconcerting result. And it's gonna make you tempted to go back and redo it and check your work, and that's totally fine. That makes sense. But if you work it through and man, you're really convinced that you've got everything correct, that is an okay place to end. No solution. So don't be overly scared of that. Okay, let's do a few more. All right, here we go. So I've got a little bit of factoring to do, but not over here. Okay, here I've got the difference of squares, so that'll be x minus 3, x plus 3. So right here I'm seeing both denominators pop up. So what I'm going to do here is my lowest common denominator is just going to be the product of those two. So I'm just going to multiply x minus 3, x plus 3 here. That is what's going to go in every numerator with the stipulation. Okay, remember now that x cannot equal plus or minus 3. Now I'm going to put that in every numerator. So this will be 2x times x minus 3, x plus 3 over x plus 3 plus x times x minus 3, x plus 3. I hope I have enough room here. Over x minus 3 is equal to 18 times x minus 3, x plus 3 over x minus 3, x plus 3. See, there's a lot of factoring, canceling going to happen here. And this is so long as, and I'm right off the edge here almost, x can't equal plus or minus 3. Get to that in a second. Sorry about that. But anyway, a lot of canceling is going to happen here. First of all, the x plus 3's will cancel as long as x doesn't equal negative 3, and I've already stated that that's the case. So this will be left with 2x times x minus 3, or 2x squared minus 6x. Awesome. Here, the x minus 3's will cancel, and that's true as long as x doesn't equal positive 3, but we've already stated can't do that, so that's okay. Now multiply the x through by x plus 3, so it'll be plus x squared plus 3x. And on the right-hand side here, wow, that's just awesome. Everything canceled. We were just left with 18. So long as x does not equal positive or negative 3. All right, well, now I got a quadratic here. So to solve that quadratic, we'll put the x squared terms together. That's going to be 3x squared. Negative 6x and positive 3 is going to be negative 3x. And then bring the 18 over to get negative 18 is equal to 0. Again, where x can't equal plus or minus 3. Now, I can divide everything through by 3 here, because this term divided by 3 will just be x squared. 3x, negative 3x divided by 3 is just going to be negative x. Negative 18 divided by 3 is negative 6. 0 divided by 3 is 0. So I can divide everything through by 3, and now I'm going to try to factor this. And my factors of negative 6 will be negative 3 and positive 2. That's the combination that add to negative 1. Now, if you try 6 and 1, you won't get this. If you try positive 3, negative 2, you still won't get the negative 1 right there. It's got to be this pattern right here, where x cannot equal plus or minus 3. And then x is either equal to positive 3 or negative 2 based on this, but x can't equal positive or negative 3. So that means I have to reject that first root. And so the only answer that we get is negative 2. Now just a little bit of vocabulary here. That 3, okay, therefore we say it like this, therefore 3 is extraneous. Okay, it's an extraneous root. And I actually could have said that with the previous question, but in this case right here, one of them is a root. It's just this extra 3 here, it didn't do anything to help. That was just what we call an extraneous root. Okay, couple more. Now, here, actually this question is going to be really nice to us in just a second, and I'll show you why here, okay? But just in a moment here. So first of all, we're going to do some factoring. So this will be 0. There's a common x up top there, and so that's going to give us x squared minus 4 over x minus 2. And my non-permissible here is x can't equal positive 2. But notice that there's a little bit more factoring that I can do. I can deal with the difference of squares here. So this will be x times x minus 2, x plus 2, all over x minus 2. Well, I like that. Again, x can't equal positive 2. those are going to cancel. That's wonderful. Now what's really neat about this question is that then I'm left with x times x plus 2, and I'm not going to expand that out quite yet, and I'll show you why in just a second here. Because this is equal to 0. See, whenever you've got like a quadratic, which is what you would get here, if you multiplied that x through, you'd get x squared plus 2x. Then what you would do is you would set it equal to 0 and factor. But the beautiful thing about this question is that the work that I did to get it down here forced me to factor it, and it was always set equal to 0 from the beginning. So now, I just have to state what my solutions are. From here, I would get that x equals 0, and from here I would get that x equals negative 2. So long as x does not equal 2, and it doesn't. And so those are both acceptable solutions. Wonderful. All right, one more. Okay, now, in this particular case here, we've got two terms here that have expressions in the denominator, both x minus 2. And so I don't have to do any factoring here. I'm just going to multiply everything through by that x minus 2 here. Okay? And so this will be 4x plus 3 times x minus 2 over x minus 2 plus 6x minus 2. There's no denominator there, so that's basically just going to stick. So 11 times x minus 2 over x minus 2. And by this time you should probably see quite clearly that x can't equal positive 2, because that would cause zeros to pop up in the denominator. Now, the x minus 2's are going to cancel, so you're going to be left with 4x plus 3 plus, there's nothing to cancel here, so I'm just going to distribute the 6 through, plus 6x minus 12. And then the x minus 2's cancel here, and we're just left with 11. That's all true, so long as x doesn't equal 2. What have we got here? Let's put the x terms together, so it'll be 10x. Positive 3 and minus 12 will be minus 9 is equal to 11, so long as x doesn't equal 2. So 10x is going to equal 20, so long as x doesn't equal 2. Oh, you might be able to see it at this point here. So x is equal to 2, so long as x doesn't equal 2. You now just think, what does that mean? That means there's no solution. Okay, turns out 2 is extraneous. It's this little root that I get. Okay, it is a root that I get out of doing the math there, but it's not an answer to the problem here, so we call it extraneous here. There is no solution to this problem. And there you go. It's good to have a couple of examples that work like that, just if for no other reason to kind of convince you that that is a possibility. It's a strong possibility that you'll get a question on an exam that has no solution to it. Just be on the lookout for it.